is Felix Nitschke. I'm assistant professor at the University of Texas Southwestern Medical Center, and I'm a biochemist by training, and my lab studies glycogen metabolism and associated diseases. And I would like to give a brief overview on possible treatment approaches in GSD4, which includes APBD. To understand how to treat GSD4 and APBD, we have to look back at the cause of the diseases. And I really like the schematic from Dr. Koch and Krishnani's recent publication. It illustrates really well how water-soluble glycogen is normally made by the concerted action of glycogen synthase and glycogen branching enzyme, GYS and GBE1. And in GSD4 and APBD, the branching enzyme is reduced by various degrees. So there's this is probably what represents the spectrum of the disease, the degree in which branching enzyme is reduced, so that glycogen chains do not get branched enough and they get too long. And as a consequence, the glycogen becomes insoluble and basically unusable for the cells. And that means it piles up basically like trash and causing all kinds of problems in the cell. In general, treatment approaches can be classified by what they aim to do. Some aim to restore the branching to elongation ratio. This means we either increase the frequency of glycogen branching or we reduce the rate of chain elongation. Other approaches aim to remove the already piled up abnormal glycogen. These therapeutic aims, restore and remove, can theoretically be achieved by different approaches. We have gene therapy, protein therapy, and therapy with non-biologic synthetic compounds. In gene therapy, a viral vector is used to provide cells with a blueprint, basically with information, for instance, on how to make a protein that the cells need. These treatments are quite long-lasting, and as a cell can basically make more protein as long as it has the blueprint. In protein therapy, the missing protein or the needed protein is produced in the lab and then injected. Because the cells cannot make the protein itself, those treatments have to be kind of repeated regularly. And then finally, we have the non-biological therapies, which include all kinds of synthetic, meaning lab-made chemicals and compounds that either interfere, for example, with the production of proteins or impact protein function in some way. Okay, so as mentioned before, to restore glycogen branching to elongation ratio, we could enhance GBE or we could downregulate glycogen synthase. And the most obvious approach is to deliver the blueprint on how to make GBE1. Dr. Krishnani has actually successfully shown proof of concept in a GBE deficient mouse model. So generally, this should work. Another gene therapy approach is to give cells the information on how to interfere with the production of glycogen synthase of GYS. Here at UT Southwestern, Dr. Manassian and I were able to show efficacy of these approaches also in GBE deficient mice. Using antisense oligonucleotides, we were also able to interfere with GYS, with glycogen synthase production in a non-biologic way. And at the same time, small molecules were identified by the groups of Drs. Cachlon, Ackman, and Roach, and these molecules act as inhibitors of glycogen synthase. Now, there are also small molecules that enhance the cell's ability to degrade abnormal glycogen. That would also be helpful in the class of removing abnormal glycogen. And Dr. Gentry at University of Florida was able to show that abnormal glycogen in mice can be degraded if the mice are injected by an antibody amylase fusion protein. And the amylase basically is the degrading enzyme that takes care of the insoluble glycogen. In my lab now, we're currently testing an approach where instead of injecting the antibody amylase fusion as a protein therapy, we're providing the cells with the information, again, the blueprint on how to make the protein themselves. This will hopefully lead to a widespread removal of abnormal glycogen. To sum this all up, there's a wide landscape of possible approaches in various states of preclinical development. However, all of these treatment approaches in one form or other basically address the unifying and underlying problem that combines all GSD4 disease categories, which is the massive buildup of abnormal glycogen. Thank you. This is Felix Nitschke. I'm a